welcome to Fascinating Frontiers, episode 129 for July 12th, 2026. Let's look at what's new across the frontiers of space and science. UN records now let anyone track satellite registrations that official sites still hide. Today's update moves the flight test cadence forward and keeps the open question of reuse intervals in view. SpaceX has begun preparations for the 13th integrated flight test of Starship. The vehicle could launch as early as July 16th from Starbase in Texas. Engineers will watch propellant transfer performance and booster catch attempts on this flight. The mission profile includes multiple engine burns after separation. Data from this flight will inform the next set of hardware changes. Now, on a completely different note, orbital analyst Jonathan McDowell reports that fresh satellite registration documents remain unavailable through the standard UNOSEA website. The same files appear on the main UN documents portal when the correct document ID string is entered. Access still requires manual guessing of identifiers rather than a searchable index. Older records have also become reachable after a tip from another user on how to navigate the archive. The workaround restores visibility into recent launches without waiting for an official interface update. Better launch visibility pairs naturally with new questions about what those launches might encounter. Researchers from Italy and Germany have modeled a lightweight permanent magnet array that could deflect solar energetic particles. The design avoids the power demands of superconducting coils and the mass penalty of water shielding. Computer simulations show the static field can reduce crew exposure during solar storms by a measurable fraction. The team's preprint explores field geometry needed to cover a small habitat module. The magnets would be mounted externally on the spacecraft structure. No cooling systems or electrical current are required. Radiation protection matters most on long voyages. One recent X-ray study shows how uneven forces already shape outcomes in space. A neutron star squeezes the mass of the Sun into a sphere roughly 20 kilometers across. A teaspoon of its material would weigh as much as a mountain on Earth. Permanent magnets proposed for spacecraft create a comparable but far weaker static field that can nudge charged particles away from a crew module without any electrical power. Picture riding alongside a solar energetic particle as it approaches the habitat. Instead of a straight path, the proton curves along the field lines and misses the thin shell by tens of meters. The geometry that works best is a simple dipole whose poles sit outside the living quarters. Even a modest field of a few Tesla can reduce the dose from a typical solar storm by 30 to 40%, according to the new simulations. The remaining puzzle is whether the same arrangement leaves gaps at the cusps near the magnetic poles. Dutch astronomers used Chandra X-ray observatory data to track the shock front of G292.0 plus 1.8. The remnant, rich in oxygen, shows faster expansion along some axes than others. The asymmetry suggests the original explosion was not perfectly spherical. Continued monitoring will test whether the pattern persists as the remnant ages. The X-ray images resolve the forward shock in multiple energy bands. Proper motion measurements over several years reveal the velocity differences. The remnant lies several thousand light years away in the southern sky. From one kind of cosmic asymmetry, we turn to objects that push the distance record even farther. Astronomers have identified two quasars farther from Earth than any previously confirmed objects. The discovery relied on spectroscopic follow-up of candidates selected from wide-field surveys. Both objects are powered by supermassive black holes accreting at high rates. Their light provides new probes of conditions in the universe less than 1 billion years after the Big Bang. The spectra show strong emission lines shifted far into the infrared. Additional candidates from the same survey are under review. Early universe extremes contrast with a very recent human milestone. Harvard astronomer Avi Loeb has been appointed to head a fresh federal study group on unidentified aerial phenomena. The panel will review sensor data and witness reports with an emphasis on scientific methods. Loeb previously led the Galileo project, which searches for technological signatures from interstellar objects. The new group's first report is expected within a year. The appointment brings an astronomer with experience in anomaly detection to the effort. Data sources will include both government and civilian instruments. Official scrutiny of anomalies sits alongside quieter national ambitions. Pakistan has formally asked NASA to explore cooperation on a lunar landing targeted for 2035. The proposal includes shared technology development and possible joint science instruments. Discussions would focus on lander systems and surface operations. The request marks the country's first public step toward independent crewed lunar capability. No formal agreement has been signed yet. The approach would build on existing bilateral space science exchanges. New partners look outward while earlier spacefarers are remembered. Alexander Alexandrov, who flew under the Intercosmos program in 1988, passed away on July 11th. He became the second Bulgarian citizen to reach orbit after Georgy Ivanov. Alexandrov's mission on Soyuz TM-5 included Earth observation and material science experiments. Colleagues remember him for his work training later crews in microgravity procedures. His flight lasted 8 days and returned safely to Earth. Alexandrov remained active in space education after retirement. Human stories of survival lead into documented close calls. A new feature lists 8 documented incidents in which astronauts survived life-threatening failures during flight. The cases span multiple nations and decades. Each example includes the specific system failure that occurred and the steps crews took to recover. The article draws on mission transcripts and post-flight reports rather than speculation. Readers see the exact sequence of events that turned potential disasters into safe returns. The incidents cover both American and Soviet-era missions. From crude close calls, we move to an entirely different kind of tracking challenge. A new caller combines GPS with SpaceX's direct-to-cell Starlink network to maintain contact anywhere on Earth. The device can send location updates and short messages even when traditional cellular coverage is absent. Developers say the caller will enter limited production later this year. It is the first commercial pet product to rely on the emerging satellite-to-phone constellation. The hardware uses the same frequency bands planned for future smartphone connections. Battery life supports multi-day tracking without recharging. Everyday technology now reaches remote places. Similar persistence appears in amateur astronomy. A Nikon Z8 paired with a Takahashi TSA 120 telescope recorded 5,400 raw frames of the lunar surface. The sequence was aligned and stacked to produce a short time-lapse showing changing shadows across craters. The mount used was a ZWO AM 5-inch high frame rate mode at 20 frames per second. Processing combined PIPP, AutoStacker, and Photoshop before final animation in After Effects. The best 10% of frames were selected for the final stack. The animation reveals subtle topographic relief under changing illumination. Ground-based imaging continues with deep sky targets under city skies. From Baghdad, a C-Star S50 telescope collected 12 hours of luminance data on NGC 6960 under light pollution filters. The resulting 1.3 times mosaic reveals fine filamentary structure in the supernova remnant. Stacking and processing were completed in PixInsight and Photoshop. The image demonstrates that useful deep sky data can be gathered from an urban site. The Vale complex lies about 1,500 light-years away in Cygnus. The observer used an EQ mode mount to track the field. One more dedicated observer closes our look at recent records. A 200mm Newtonian telescope gathered 26 hours of luminance, 7 hours of RGB, and 2.5 hours of H-alpha on NGC 6946. Two cooled CMOS cameras operating at -15 degrees Celsius captured the data from a Bortle 4 location. The final image shows star-forming regions and dust lanes across the spiral arms. Processing used PixInsight, SETI Astro Tools, and Photoshop. The galaxy lies roughly 25 million light-years away in Cepheus. The long luminance exposure brings out faint outer structures. The H-alpha data highlight active star-forming complexes. Polarization measurements add another layer to X-ray views of compact objects. The Imaging X-ray Polarimetry Explorer has mapped the magnetic field geometry around a pulsar nicknamed the Lighthouse. Polarization measurements show the field lines twist in ways that match theoretical predictions for a rotating neutron star. The data cover multiple rotation phases and provide the first direct view of the emission region's orientation. Follow-up observations are planned to test whether the pattern changes over months. The pulsar emits beams that sweep across the line of sight like a lighthouse. IXPE's detectors record the angle of polarized X-rays from each phase. The results constrain models of the magnetosphere. Planetary surfaces also reveal ongoing processes that leave no lasting trace. In the planet's polar regions, carbon dioxide freezes and precipitates as fine crystals that sublimate before reaching the surface. NASA's MARSIS radar has mapped layers of this dry ice several kilometers thick. Beneath the ice, the same instrument has detected what appears to be liquid water that has persisted for billions of years. The snowfall occurs only where temperatures drop below minus 125 degrees Celsius. The radar reflections distinguish the ice layers from underlying rock and liquid. No surface deposit forms because the crystals disappear in the thin atmosphere. The process repeats each Martian winter. Next time, we'll be watching for the first report from the new UAP study group. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Modern investing techniques, modern strategies for Canadian and US investors. Find every show free at naranetwork.com. The Do Positive Pod is the club for people who do something about it. Episodes and the dispatch wall at naranetwork.com/thedppod. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting south